Hello students and friends, welcome to Thrust of Curiosity. In this video, we are going to start how to find out the inverse of a matrix. Now basically we have three different methods to find out the matrix inverse. One is the Gauss Jorden method, or usually we call this as a row transformation method, or we can also do with the column transformation. Another method is the adjoint method. It is considered to be very easy if the matrix is 2 by 2, but if the higher order matrix is there, then it will become difficult. It is also good for a 3 by 3 matrix. And then last one is a Cayley-Hamilton theorem. We will also see by using Cayley-Hamilton theorem. Now first of all we will see what is inverse. Usually what we do in algebra also, we have different type of 2 plus x is equal to 0. So if this is true, then x is called as a additive inverse. Okay, so obviously we know the value is minus 2. If 2 into x is equal to 1, then this x is called as a multiplicative inverse. Okay, so the value of x in this case will be half, in this case this will be minus 2. So minus 2 is a additive inverse of plus 2 and half is a multiplicative inverse of plus 2, right? Now in case of matrices, here inverse means multiplicative inverse. So suppose A into B is equal to I, because here is 1, here we have unit matrix or identity matrix that we call as I. So if this is true, then B is called as an inverse of A. A is also inverse of matrix B. Or in general we will write A into A inverse is equal to I, or this is also equal to A inverse into A. Okay, how we write this? Whether I write A inverse equal to I or A inverse A is equal to I. Depending on that, we have to use row transformation or column transformation. We will try to solve by both methods. So in this lecture we will only focus on Gauss Jorden method or transformation method. As we did earlier, we started 2 by 2 matrix. Okay, this is a matrix A. Now it is mandatory that for any matrix, if we have to find out the inverse, that matrix should be non-singular. So you should know what is singular matrix. Okay, so if the determinant of the matrix is equal to 0, then that matrix is called as a singular matrix. And if the matrix has a 0 determinant, then we cannot find its inverse. This you should know. Okay, so let's confirm that this matrix is having non-zero determinant. So 2 into 2 minus 1 into 1. So it has determinant equal to 5. Okay, so it is non-zero. So this is mandatory. Determinant of A is not equal to 0. What is value is not required in this method at least. We require this in adjoint method. We require what is the determinant of that particular matrix. We have to use that. Okay. And if you know what is the determinant of that particular matrix, okay. So in this case, this determinant of A is equal to 5. Right? We have to write A into A inverse is equal to I in this format. And if I am writing in this format, in Gauss Jorden method, we will use row transformation method. Okay? So I will write 2 1 minus 1 2 into A inverse is equal to 1 0 0 1. Now what we will do? We will make changes in this matrix and in this matrix simultaneously, so that this matrix will turn into identity matrix. And if it becomes identity matrix, then we know if we multiply by 1 to any number, the number itself is the answer. Same is true with the matrices. If I multiply any matrix with I, the matrix will remain that same matrix. So I into A inverse will become A inverse. So when I will transform this matrix into unit matrix or identity matrix, I will convert this identity matrix into the inverse of the given matrix. Okay. So what we have to do in this configuration, we have to use the row transformation. Whatever changes we have to make the changes in the row, not in the column. Okay. So this is the first row, this is the second row. This is first column, second column. So what we have to do? We have to do row transformation, means we have to use, let's say, R1 and R2. We can only change R1 and R2. We can add them, we can multiply by some number to them, we can do whatever we want. Such that we have to convert this matrix into identity matrix, that is 1001. So first you should try how to do. What will be the easier method to do this? So one thing we should do, first make this element equal to 1. Then make this element equal to 1, or make this element equal to 0. So we can go like this, in this make this equal to 1, then make this equal to 0, then make this equal to 1, then make this equal to 0. We will see. Or reverse is also true, but not starting with this. Starting with this, the element which in the end will become 1, you have to start with that only. Okay. So let's do this equal to 1. How can I do? I can add this 2. If I add R1 plus R2, then what will happen? 2 minus 1 will become 1. There is alternative method also. I can divide row 1 by 2. So I will get here 1 and here I will get half. But again the fractions will make us problem during the calculation. So it is easier, maximum time you should try with addition or subtraction. If necessary, then only go for multiplication. So I will change R1 to R1 plus R2. So this is mandatory to write. How I am going to change? Which matrix is going to change? I am going to change R1 and replace with what? R1 plus R2. This is just to remember what I am doing. Whatever I am doing with this, I also have to do with identity matrix or matrix on the right hand side. So I will go with this first. So R1 I will change. So R2 will be as it is. So minus 1, 2. I will keep this as it is. Now R1 plus R2, 2 minus 1 is plus 1 and 1 plus 2 is equal to 2. A inverse is equal to. Second row is same. First row will change to R1 plus R2. So 1 plus 0 is 1. 0 plus 1 is 1. Sometimes we forget to do the calculations on the right hand side. So you should not forget this. Now I have to make this 0. How can I make this 0? I can add R1 to R2. So R2 changes to R2 plus R1. So what I will get? 1, 3. First row is same. 1 minus 1 is 0. 3 minus 5. Sorry, 3 plus 2 is 5. Inverse is equal to. First row is same. For second row, we have to add. So 1 plus 0 is 1 and 1 plus 1 is 2. Now, here I have to use division. I cannot do this with addition or subtraction, because if I add R1 again by some multiplicative factor, this 0 will vanish. 0 plus something will be there. So to maintain this 0, I have to divide by some number. If I do 5 divided by 5, then I will get only here equal to 1. So how I have to write? I don't have to change only this element, I have to change this row, because it is a row transformation. So R2 is going to change to R2 divided by 5. Okay. And now we can write this first row will be as it is and divide by 5, so this will become 0 by 5 is 0, 5 by 5 is 1. A inverse is equal to first row is as it is and divide by 5 to this element, this both elements. So 1 by 5. Now there is no chance, we have to use fractions. And now one last element is remaining, this. If this is becoming 0, then I will convert this into a unit matrix. So what I have to do? I have to add 3R2, subtract 3R2 from R1. Then what I will get? R1 has to be changed, R1 minus 3R2. Multiply by 3 to this matrix, to this row, and then subtract from first row. Then what we will get? First row has to change, second row will remain as it is. So 1 minus 3 into 0. So 1 is not going to change. 1 minus 0 is 1. 3 minus 3 into 1 is 3 minus 3 is 0. Now on this second row will be as it is, 2 by 5 and 1 by 5 and 2 by 5. This will be as it is. Now 1 minus 3 into 1 by 5. So I will do it over here. 1 minus 3 by 5. So 5 minus 3 is 2 by 5, right? So this is 2 by 5 here. And 1 minus this element, 1 minus 2 into 3 is 6 by 5. 1 minus 6 by 5. So again this will be 6. 5 minus 6 minus 1 by 5. And because this is a matrix, I can take common from all elements. So this will be equal to, now this is I. So I into A inverse is A inverse itself. So I can write A inverse here. I can take 1 by 5 common from all sides. 1 by 5. Now 2 minus 1, 1, 2. Now because this is 2 by 2 matrix, I already told, cofactor method will be, or adjoint method will be very easy to solve. You can see both matrices. There is merely difference of minus sign. 2 by 2, because it is 2 by 2 matrix. 3 by 3 matrix it will be little complicated. But I wanted to tell you one trick, right? I will first solve and then I will tell you. The determinant of the matrix will be in the denominator. That is one thing you should check. Whether your calculation is right or wrong, how can you check? Whether the determinant of the matrix is in the denominator of out. If the determinant is equal to 1, then it is difficult to find. But if it is other than 1, then you can find out. Okay, if 1 upon 5 is there, then my answer is correct. Find out the inverse of given 3 by 3 matrix. Now because it is a triangular matrix, some steps we have saved, so time is also saved, but the process is the same. Now if these three elements are not 0, we will first make them 0. First we will make this element 0 using this, then we will make this 0 using this first row. Then we will make this element equal to 1 using first row, and then using this we will make this 0 and this 0, and in the end we will make this element first equal to 1 and then remaining. So in any row or any column, we will first try to make the element which has to become 1, and then using that we will make other two or other remaining elements must be equal to 0. So I will make changes here itself. So this matrix A into A inverse is equal to I, that is 1 0 0 0 1 0 0 0. Okay, what will be the determinant of this? 1 into 24. This will be your determinant. 8. So 1 upon 8 should be there in my answer. This is your trick. So that way you can find out whether my calculations are correct or not. Okay, so because all three elements are already 0, I have to make this element equal to 1. How can I do this? I have again two different methods. I can divide this by 2, or I can add this. Which one I should use? Divide. Because if I add this 0 will vanish. Okay, you should think like that. Okay, so because I don't want to spoil this 0, I have to divide this or make this equal to 0 first. But the calculation will become lengthy. So I will make this 1 by dividing by 2. So R2 will change to R2 divided by 2. Okay, now find out R1 is as it is 1 minus 1 3. Now divide by 2, 0 1 2. Third is as it is. A inverse is equal to 1 0 0. First row as it is, third row as it is, and in second row we have to divide by 2. So 0 half 0. Now I can make this 0 or I can make this 1. So if I do this, that will be easier. In next step, I can get directly what is the inverse. If you are good in calculations, then we can do that. So I will first make this element equal to 1. R3 changes to R3 by 4. Again, division is compulsory, otherwise this zeros will spoil. So I will get here 1 minus 1 3 as it is, 0 1 2 as it is, 0 0 and 1 into A inverse is equal to, again here first two rows will be as it is, 0 1 0, sorry 0 1 0 0, 0 half 0, 0 0 1 by 4. Now I will make this equal to 0. So R2 changes to R2 minus, this is 2, so if this has to become 0, I have to multiply by 2 to R3 and then subtract. So minus 2 R3. So I will get first row will be as it is, second row will change to 0 1 0, third row as it is, 0 0 1. A inverse is equal to first and third row will be as it is, 1 0 0 0 0 1 by 4. Now what we have to do? R2 minus 2 R3. Here you should be careful. R2 is half. First element is 0. 0 minus 0 will be 0. The first element will be 0 as it is. Second element half minus 0. So again it will be half as it is. Now third element 0 minus 2 into 1 by 1 is half. So this will be minus 2 by 4 means half. So we have to subtract that. Therefore it will become minus half. Now we are just one step away, or you can say 2 steps away, but I can use one trick. Because other two elements are 0 in the second row and third row, I can use combination of both and make these two elements 0 in a single step. But to do that, we should be able to do this calculation also. This is a little bit tricky. So this we can do in the steps, or if it is possible to you, you can do in one step. So what I have to do, I have to change R1 to R1 minus or R1 plus R2. Okay, if I do R1 plus R2, this element will become 0. And to become this element 0, what I have to do, I have to subtract 3R3. So I can do this in a single step, or you can do it in 2 different steps. Okay, so if I do this, here I will get I is equal. So we have to change in first row. So I will keep second and third row as it is. 0 half minus half, 0 0 1 by 4. Okay, what we have to do? We have to do 1 plus 0 minus 0. So this will become 1. First element, no issue. Second, 0 plus half minus 0. So this will be half. Now third element, 0 plus half minus, so 0 R2 is minus half minus 3 by 4. We have to do here. So if I make the denominators equal 4, so this is equal to minus 2 minus 3 upon 4. I multiply this 2 on the denominator as well as numerators to make this denominators equal. So minus 2 minus 3, so this will be minus 5 by 4. Now can you see 1 by 8 in the denominator or as a common? You can understand. Okay. If I take 1 by 2 and 1 by 4 common, 1 by 2 into 1 by 4, that is 1 by 8. So if I take 1 by 8 common, and you should remember that okay, we can also take 4 also common, but I know I have to take 8 common because 8 is my determinant. I can do this, or I can also take 1 by 4. 4 also is okay. So if I take 4 common, I will write 4 here. Here it will be 2 minus 5, 0, 2 minus 2, 0, 0. 4 is common, but I can also take 8 also common. So this calculation might be correct. I am not sure whether it is definitely correct, but you cross check this. What we can do? We can multiply this original matrix and that matrix, and we can find out whether the answer product is equal to identity matrix or not.